Good day everyone. Our topic will be about our chosen course, Civil Engineering, which will be discussed by our group. Mr. Monteras, Mr. Paranada, Mr. Parico, Mr. Ponay, I, Ms. Benaventura, Ms. De Leon, Ms. Ramos, Ms. Ronquillo, and Ms. Tadena. This is the Civil Engineering overview and discussion.
This report aims to develop students' construction-related problem-solving skills using the latest technologies, to equip students with knowledge of sustainable developments for the improvement of the living environment and the preservation of the natural environment, to understand ethical issues associated with their profession and be able to apply their acquired knowledge and skills to the betterment of society, to equip students with sound skills in construction technology and management, enabling them to better meet the needs of the society and gain more flexibility in their choice of career, to prepare graduates for future professional career developments or pursuing their postgraduate studies in the fields of engineering and management.
Before we start, we would like to give an outline of our topic. First off, starting with the history of civil engineering, which will cover how it evolves into the profession it is today, followed by the introduction of its subdisciplines, including coastal, environmental, and transportation engineering, to give a few examples. To begin, here is Miss Guinevere, who will lead us to the start of the presentation.
First, we will tackle the history of civil engineering. What is civil engineering? Civil engineering is a professional engineering discipline that deals with the design, construction, and maintenance of the physical and naturally built environment, including public works such as roads, bridges, canals, dams, airports, sewage systems, pipelines, structural components of the buildings, and railways. Civil engineering is traditionally broken into a number of subdisciplines. It is considered the second oldest engineering discipline after military engineering. Civil engineering can take place in the public sector from municipal public work departments through to federal government agencies, and in the private sector from locally based firms to global Fortune 500 companies. Civil engineering yung reason behind the designs and stability ng foundation of a building or constructions. Yung mga nakikita nating buildings, yung mga mall, airports, yung mga tulay, lahat yan nagsisimula sa civil engineering. Civil engineering as discipline. Throughout ancient and medieval history, most architectural design and construction was carried out by artisans such as stonemasons and carpenters, rising to the role of master builder. Knowledge was retained in guilds and seldom supplanted by advances. Structures, roads, and infrastructure that existed were repetitive, and increases in scale were incremental. Civil engineering became a norm or an activity na tuloy-tuloy na ginagamit and tuloy-tuloy na nag-evolve. And because of that, nagkaroon pa ng ibang field yung civil engineering. Mga disciplines like geotechnical, coastal, construction, and many more other fields. One of the earliest examples of a scientific approach to physical and mathematical problems applicable to civil engineering is the work of Archimedes in the 3rd century BC, including Archimedes' principle, which underpins our understanding of buoyancy, and practical solutions such as Archimedes' screw. Brahmagupta, an Indian mathematician, used arithmetic in the 7th century AD based on Hindu-Arabic numerals for excavation computations. Yung civil engineering, nagkaroon siya ng physical and mathematical approaches, and yung mga kauna-unahang approaches na yun ay yung Archimedes principle na work of Archimedes, and yung arithmetic na ginagamit for volume computations na pinropose naman ni Brahmagupta. Civil engineering as profession. John Smeaton is the father of civil engineering. In 18th century, the term civil engineering was coined to incorporate all things civilian as opposed to military engineering. In 1747, the first institution for the teaching of civil engineering was established in France. And more examples followed in other European countries like Spain. The first self-proclaimed civil engineering was John Smeaton, who constructed the Eddystone Lighthouse. In 1771, Smeaton and some of his colleagues formed the Smeatonian Society of Civil Engineers, a group of leaders of the profession who met informally over dinner. Though there was evidence of some technical meetings, it was little more than a social society. Civil engineering as education. The first private college to teach civil engineering in the United States was Norwich University, founded in 1819 by Captain Alden Partridge. The first degree in civil engineering in the United States was awarded by Rensselaer Polytechnic Institute in 1835. The first such degree to be awarded to a woman was granted by Cornell University to Nora Stanton Blatch in 1905. Of course, before maging civil engineer, kailangan muna nating pag-aralan ng civil engineering. So it became an education. And yung unang school na nagturo ng civil engineering ay yung school sa US, which is the Norwich University. And then yung unang school na nagbigay ng degree in civil engineering is sa US din, which is yung Rensselaer Polytechnic Institute.
What is coastal engineering? Coastal engineering is a branch of civil engineering that deals with the unique challenges that come with building on or near the coast, as well as the development of coast itself. Coastal engineers, as explained previously, have a basic understanding of the characteristics and physical behavior of the coastal environment, as well as the ability to apply engineering principles and concepts to developing opportunities and solving problems in the environment. Functions and responsibilities of coastal engineer. The majority of the world's population lives near coastal areas, and the prized real estate are prone to the constant dangers of erosion. Erosion preventions and the protection of coastline are major responsibilities of coastal engineer. So coastal engineers must build a project that will solve the problems of erosions. As a result, coastal engineers must devise a strategy and build a structure that will assist the community in defending against disasters such as erosion and storm waves. What do coastal engineers construct? Seawalls are primarily intended to resist waves while also retaining some soil, whereas bulkheads are primarily intended to retain soil while also resisting waves. Coastal engineers' common projects are artificial sand dunes, seawalls, revetments, breakwaters, jetties, groins, and bulkheads. Improperly designed groins can also worsen erosion on the downdrift side.
It may be helpful to begin with an overview of the role, how it differs from civil engineering, and what construction engineering professionals do on job sites. The construction engineering is the management and delivery of construction projects. Construction is considered to be any building projects used for residential, commercial, or industrial applications. The civil engineering focuses on the design, planning, and analysis of a construction project, whereas the construction engineering focuses on the actual construction management that are educated in the field of construction management that are classified as construction engineers. The construction engineers are civil engineers who have received training in the subject of construction management. Construction engineers inspect each part of the construction to verify those codes are being implemented by the workers. A construction engineer may work on many different types of projects. These are large buildings, electrical systems, and mechanical systems. A construction engineer may be responsible for the strategic design and completion of large, complex buildings such as airports, commercial facilities, or office complexes. Construction engineers may also manage the development of large-scale electrical systems to safely and reliably supply power to buildings or group of buildings. Additionally, construction engineers may oversee the completion of mechanical systems, which can include elevators, escalators, indoor heating and cooling systems, and plumbing systems. A construction engineer may be tasked with building a new highway or tunnel, or with ensuring that a new building or group of buildings is properly connected to main roads, ensuring accessibility. Some general areas of a construction engineer's responsibility are creating budgets for the construction process. They also assemble necessary equipment and materials. They build and supervise a team of construction and engineering professionals. They oversee the progress and safety of the building process and report back to stakeholders. They use machinery or other advanced tools, and also they use computer software to confirm or modify design specifications. Construction engineering is critical to the building and upkeep of our homes, workplaces, communities, and public areas, because this professional path encompasses so many subspecialties. It provides a plethora of exciting job options. Construction engineering is a globally important building business. First, it has proven extremely durable in the face of the global slump and the substantial drop in housing-related construction, as has the civil engineering sector. As a result, it will represent a significant share of global construction activity during the next 10 years. Second, it plays a critical role in the implementation of global energy strategy on both the supply and demand sides. Engineering construction is the delivery mechanism for the world's energy infrastructure, including electricity, oil, and gas, as well as industrial processing facilities, which account for a third of global energy consumption. Creating a picture of managing engineering construction allows a tentative form of a research agenda for engineering construction to be developed.
Let's talk about earthquake engineering. The road to success is always under construction. What exactly is earthquake engineering? It is an interdisciplinary branch of engineering that designs and analyzes structures, such as buildings and bridges, with earthquakes in mind. Its overall goal is to make such structures more resistant to earthquakes. An earthquake or seismic engineer aims to construct structures that will not be damaged in minor shaking and will avoid serious damage or collapse in a major earthquake. Earthquake engineering is the scientific field concerned with protecting society, the natural environment, and the man-made environment from earthquakes by limiting the seismic risk to socio-economically acceptable levels. Traditionally, it has been narrowly defined as the study of the behavior of structures and geostructures subject to seismic loading. It is considered as a subset of structural engineering, geotechnical engineering, mechanical engineering, chemical engineering, applied physics, etc. However, the tremendous cost experienced in recent earthquakes have led to an expansion of its scope to encompass disciplines from the wider field of civil engineering, mechanical engineering, nuclear engineering, and from the social sciences, especially sociology, political science, economics, and finance. Earthquake or seismic performance defines a structure's ability to sustain its main functions, such as its safety and serviceability, after a particular earthquake exposure. A structure is normally considered safe if it does not endanger the lives and well-being of those in or around it by partially or completely collapsing. The next one is the aims of earthquake engineering. The science of the performance or buildings and the structures when subjected to seismic loading. It also assists analyzing the interaction between civil infrastructure and the ground, including the consequences of earthquakes on structures. Earthquake engineering has evolved from using a set of prescriptive provisions and directly aimed at providing life safety to performance-based approaches with direct consideration of a range of performance objectives, such as minimizing the repair cost of the facility under a range of earthquake shaking intensities. A properly engineered structure does not necessarily have to be extremely strong or expensive. It has to be properly designed to withstand the seismic effects while sustaining an acceptable level of damage. Here is the main objectives of earthquake engineering. Research for earthquake engineering means both field and analytical investigation or experimentation intended for discovery and scientific explanation of earthquake engineering related facts, revision of conventional concepts in the light of new findings.
Environmental engineering. Examples of environmental engineering projects are dams, system for recycling and reusing building waste in construction, municipal water supply and wastewater treatment facilities, plants to desalinate ocean water to irrigate crops, systems that assist refineries in reducing air pollutants. Environmental engineering is the branch of engineering that is concerned with ensuring people's health from the effect of adverse environmental effects, such as pollution, as well as improving environmental quality. Environmental engineering is the use of science and engineering principles to improve the environment, such as providing clean water, air, and land for human habitation and other living things, and rehabilitating contaminated places. So that means environmental engineering not only help human but also animals and other living things. What do environmental engineers do? Create projects that helps to protect the environment, such as water reclamation facilities or air pollution control systems. Provide technical assistance for environmental cleanup initiatives. Keep records of how environmental improvement efforts are progressing. Inspect industrial and municipal facilities and programs in order to ensure a compliance with environmental regulations.
Geotechnical engineering is the study of the behavior of soils under the influence of floating forces and soil-water interaction. This knowledge is applied to the design of foundation, retaining walls, earth dams, clay liners, and geoscientifics for waste containment. So bale, yung geotechnical engineering is important kasi study niya yung land which is beneficial for gawaing dam, retaining walls, and etc. It's important din kasi pinag-aaralan nito ang lakas at tibay ng lupa. From a scientific perspective, geotechnical engineering largely involves defining the soil strength and deformation properties. Clay, slate, sand, rock, and snow are important materials in geotechnics. Meaning to say, ang geotechnical engineering ay isang study of characteristics behavior ng soil under the presence of a force and reaction between water and soil. Studying geotechnical engineering. Education in geotechnical engineering is offered as a master's degree specialization within civil engineering. In Norway, most geotechnical engineers gain their qualifications at the Geotechnical Engineering Group at NTNU. Ang meaning ng NTNU, Norwegian University of Science and Technology. Bale, ang Geotechnical Engineering Group sa NTNU has focused on computational geotechnics complemented by extensive field work and advanced testing of geomaterials. Nagre-research sila para sa safe, environmentally sound, and cost-effective solution for the built-in structure.
Material Science and Engineering. Material Science and Engineering provides an international medium for the publication of theoretical and experimental studies related to the load-bearing capacity of materials as influenced by their basic properties, processing history, microstructure, and operating environment. They investigate how the materials perform and why the materials sometimes fail. That's why the right materials are required to produce any engineered device, structure, or product. Types of projects. The first one is the biomaterials. They develop innovative technologies to address biological challenges such as wound healing, organ transplants, and slowing the spread of cancer throughout the body. The next one is the computational materials. They explore how materials behave and accelerate the discovery of new materials using physical modeling and machine learning. The third one is the functional materials. They use the unique properties of materials to develop new technologies for sustainable energy, biological, and defense applications. The last one is structural materials. They create innovative processing methods and advanced materials for real-world application from body protection to space exploration. Roles of material science and engineering. Material science is an important part of forensic engineering and failure analysis. They investigate materials, products, structures, or components which fail or do not work as intended that can cause a personal injury or damage to a property. Investigations are important in determining the reasons of such accidents and incidents. Material scientist develops or synthesizes new materials. This involves investigating the relationship that exists between the structure and the properties of the materials, and it also teaches about the materials which objects are made of and how they react. Materials engineering is designing or engineering the structure of a material to produce predetermined set of properties. This demonstrates how to apply knowledge to create and improve things. Materials engineer is called upon to create new products or systems using existing materials and or to develop techniques for processing materials. They make sure that the materials used are suitable, and they also offer guidance on the best materials to use for a project. More info about material science and engineering. They develop, process, and test materials which are used to create a range of products. They study the properties and structures of metals, plastics, ceramics, composites, nanomaterials, and other substances in order to create new materials that meet mechanical, electrical, or chemical requirements. They help select materials for specific products and develop new ways for existing materials.
What is structural engineering? Structural engineering is a branch of civil engineering that involves the application of the laws of physics, mathematics, and empirical knowledge to safely design the bones and load-bearing elements of man-made structures. Modern-day structural engineering provides a large and detailed body of knowledge that can accurately predict the performance of different shapes and materials used in structures to resist loads and stresses on structures. Structural engineering is the art of economically designing buildings, bridges, and other structures to support their contents and protect them from extreme environmental events such as wind, snow, fire, or earthquake. Structural engineering is a specialty within civil engineering. Structural engineers create drawings and specifications, perform calculations, review the work of other engineers, write reports and evaluations, and observe construction sites. A professional engineer's license is required in order to practice structural engineering. A license can be obtained only after completing a prescribed amount of education and work experience, and taking to the exam. In structural engineering, as a structural engineer, we will only have the knowledge of constructing the structures of buildings, bridges, and our houses and how it is going to protect the people or animals from natural disasters or any other disasters that will happen. What do structural engineers do? Structural engineers are trained professionals who are responsible for making sure that the structures we use in our daily lives, like bridges and tall buildings, are safe, stable, and don't collapse under applied loads. They do this by applying their technical knowledge to specify different types of construction materials in various shapes and geometries, and design structures that can withstand the pressures and stresses of their environment, such as gravity loads, storms, and earthquakes. Just like I said earlier, structural engineers are building safe structures for tall buildings and bridges. Where do structural engineers work? Most structural engineers work either for construction or engineering consultancies, where they focus on designing structures and tend to work in an office environment, or for contractors, where they will oversee the construction of the structure working on site. Structural engineers are brought on a project if an owner is planning on changing the use of a building, introducing more floors to a building, or adding significant expansion to a building. It's very important to understand that introducing alterations to any structural element without consulting a professional engineer may result in serious damage to the structure and in some cases partial or extensive collapse of the building. Structural engineers are also brought on board if there is damage to a structure due to fire, erosion, environmental deterioration, impact, or wear and tear that could result in a loss of capacity and impose threat to the public safety. When a structural engineer is contacted for an assessment of an existing building, they will visually inspect the structure and determine the structural integrity of the load-bearing elements. Potential concerns regarding the occupant's safety suggest repair techniques and recommend structural details to restore the structure to its original conditions in order to resist the applied tools. Just like it said in the second paragraph, you can't bring other engineers than structural engineers on planning the change of a building because structural engineers are more knowledgeable about constructing a building. Dinadala rin nila sa mga na-damage na buildings para i-inspect ang mga na-damage o mga nagiging threat sa public safety para malaman kung paano ayusin ito.
Transportation engineering. This is another subdiscipline of civil engineering. An engineer of this kind has the responsibility of planning, designing, and building, as well as operating and maintaining all systems of transport in such a way as to provide for the safe, efficient, and convenient movement of people and goods. So any systems that transport humans and or materials falls under the scope of transportation engineering, which includes highways and roadways, railways, oil pipelines, public transport systems, traffic control systems, and space transport systems, among other things. Now, you ask, what exactly is the job of a transportation engineer? Railways, buses, highways, and airport systems are very complex infrastructures that require thorough planning and development. This is the main reason why we have transportation engineers. They are the ones responsible for all transport systems that we use today. They can work for governmental agencies, for consulting firms that troubleshoot for the government. They may also work for private firms that produce materials and equipment that are used in transportation. While engineers usually do office work, they are also required to work in, visit, and supervise construction sites. Some transportation engineers have their own specializations. For example, traffic engineers plan new roads or traffic patterns, while railroad engineers plan for high-speed rail services. Some engineers also develop the entire transport systems, including roads, subways, commuter trains, and buses. Specifically, these are most of the specializations in transportation engineering. First off, we have railway engineering or railroad engineering. This deals with the design, construction, and operation of all types of rail transport systems. Secondly, we have highway engineering, or also known as bridge engineering. This is another specialist field which involves the planning, designing, construction, operation, and maintenance of highways, bridges, roads, and other vehicular facilities as its name implies. Thirdly, we have port and harbor engineering. Now, this is not to be confused with marine engineering, as port and harbor engineers handle the design and construction of ports, harbors, canals, and other maritime facilities. Moving on to airport engineering. In this kind of engineering, airport engineers design and construct airport facilities. Their duties include providing runways for aircraft to take off and land, as well as terminals for safe loading and unloading of passengers and cargoes. Lastly, we have pipeline engineering. And in this field, pipeline engineers design and construct pipe systems for transporting a variety of substances such as gas and oil. They may perform site surveys, develop designs for pipeline systems, as well as construct and install infrastructure for commercial and industrial purposes. Now, with all of that said, how significant exactly is transportation engineering? Transportation has always been important in the development of society in terms of trade routes and harbors initially, but more recently in terms of land and air-based systems. The importance of transportation of a country is comparable to the veins in the human body. Just as veins help with the flow and distribution of blood and oxygen to the rest of our body, similarly, transportation keeps the health of a nation in a good condition by enabling an efficient and safe movement of human beings, materials, and goods of all kinds from one place to another. To put it simply, through transportation engineering, communities are able to develop and prosper. This profession helps in providing an efficient way of transportation, whether be it on land, air, or sea, which is very important to the economy of a society.
Two schools that offer civil engineering course are Mapua University and TIP, or Technological Institute of the Philippines. Civil engineering is a 5-year course in which tinuturo yung mga basic fundamentals ng math and science na importante sa civil engineering. And bukod sa Mapua and TIP, other schools na nag-offer ng civil engineering course ay UST, De La Salle, BSU, UP, UE at marami pa pong iba.
Hello, I'm John Patrick Go and I live in San Jose del Monte, Bulacan. I'm 24 years old, male. College degree obtained is Bachelor of Science in Civil Engineering. School where college degree was obtained, Technological Institute of the Philippines, Manila, or TIP Manila. Year graduated is year 2019. How long did you study this course? 5 years. Who chose this course and why? I personally chose this course. Why? Civil engineering, because I love managing people and seeing projects constructed. Where are you working now? Name of company. I work in LG Transtel Corporation, located in Quezon City. How long have you been working in this company? If it is fine for you to answer, what's the name of the first company and why did you leave that company? I'm working on this company for 1 year span, and this is my second company. And the first company I worked for is Kennedy Energy Development Corporation. Why did you leave that company? Because there's more opportunity there. Number 12, what's your position? Site engineer. When did you get a job? Approximately last year, March 2021. How did you know about this job? From my friend, referral. Is your job closely related in the degree obtained? Yes, the job is closely related. If it is fine to ask, how much is your salary? Salary. Approximately 18 to 20 monthly. 17. Is your salary commensurate with the course you obtain? Maybe, yes. That's all.
Hi, good day. I am Engineer Andres C. Arevalo, currently residing at Calzadang Bago 2, Imus City, Cavite. I am 45 years old and obviously I am male. I graduated as Bachelor of Science in Civil Engineering in Rizal Technological University in 1999. Civil Engineering is a 5-year course and I took it for 5 years. Civil Engineering is my own choice because I love mathematics and solving problems, and I want also to pursue the dreams of my older brother. Now I am currently working at Santa Clara International Corporation for more than a year now. My first company is Geotesting International Incorporated. So between Geotesting and Santa Clara, there are more companies in between. I have to leave Geotesting because I have to go and work abroad. Currently, I am holding a position of Senior QA/QC Engineer or Quality Assurance and Quality Control Engineer. I started here in Santa Clara last January 2021 and I applied online via JobStreet. My work here is very much related in the course I took because Santa Clara company is a construction company. Currently, I am receiving 40,000 pesos per month plus special project allowance, and yes, it is very much corresponds and proportion to my degree and experience. Thank you.
Civil engineering. We shape our buildings, thereafter they shape us. What exactly civil engineering is? Civil engineering is an exciting profession because at the end of the day, you can see the results of your work, whether this is a completed bridge, a high-rise building, a subway station, or a hydroelectric dam. Why civil engineering is important? It is very important because it plays a crucial role in the development of underground utility networks, the distribution of electrical and telecommunication networks, bus service networks, and more. Water resource engineering, a subdiscipline of civil engineering, is concerned with the collection and management of water resources. They also help people resolve different environmental issues that were caused by the hands of humanity. Geotechnical engineering, planning, or material transportation is important to reduce the levels of pollution and help us survive. We have already treated our planet in so many different ways. There are also benefits of being civil engineering. All humans benefit from civil engineering. You can thank civil engineers every time you use an electrical device, turn on a tap, take public transportation, or drive on a road. Civil engineers are responsible for the buildings, structures, and major public works projects that make modern life possible. They also contribute to the well-being of people, ensure comfort, and create a safe environment for others. Their work is essential in the modern world, so you should try yourself in engineering and never underestimate their input in the country's well-being.